Here is part 2 of Wind Always Stirring Things Up. We will start on page 56 where we left off on making an anemometer. Here's a simple version of a rotation anemometer that you can use to observe changes in wind speed. Here's what you'll need: scissors, large plastic cup, pencil with eraser, packing tape, 4 small paper cups, stapler, 2 straws, square of sturdy cardboard, and a push pin. Here's what you do. Poke a hole through the bottom of the large cup so that the pencil will slide through. Tape the cup to the cardboard and push the pencil through the hole. Cut off the tops of the small cups so they're about 1 inch deep. Make an identifying mark on one of the cups. Tape or staple a cup onto each end of the straws, one facing in one direction and one facing in the other. 3. Staple the straws into an X shape and attach them to the pencil eraser with a push pin. 4. Set your anemometer outside. Put some rocks on the cardboard to steady it if necessary. Observe your anemometer in several situations and each time record the number of revolutions the marked cup makes in 1 minute. Now you have a basis for knowing whether the wind is picking up or slowing down. Weather words. An anemometer measures wind speed in miles per hour or kilometers per hour. A rotation anemometer, standard equipment in most weather stations, has 3 or more cone-shaped cups that rotate on a pivot. The number of rotations per minute translates to a certain wind speed. Ask Mark, how high does the wind go? Does an airplane pilot flying at 30,000 feet have to worry about wind direction and speed? Strong winds can be found up to 70,000 feet. The air way up there is so thin that it's difficult for aircraft to fly much higher. Pilots need to pay special attention to the winds. A pilot can ride the wind the same way a raft rides currents in a river, getting from one place to another more quickly and using less fuel. However, if the winds aren't favorable, pilots avoid them because they slow the plane down too much. Ask Mark, how does wind speed affect your forecast? Because the wind brings air from one place to another, knowing where the air is coming from gives me a good clue about what kind of weather to predict. Strong winds also affect many outdoor activities like sailing, hiking, biking, baseball, and football. And they can be dangerous, knocking down tree limbs and power lines, or causing snowdrifts on the roads, so I need to warn people whenever high winds might create hazardous conditions. Breeze or gale, check the Beaufort scale. In 1806, Sir Francis Beaufort, an English admiral, came up with a method of measuring wind speed on a scale of 1 to 12 by observing the effect of wind on a fully rigged sailing ship. The scale was named after him, and later descriptions of wind effects on land were added. 0 is calm, smoke rises, 0 miles per hour. 1 would be light air, smoke drifts 1 to 3 miles per hour. 2 is a slight breeze, leaves rustle, wind vanes move, 4 to 7 miles per hour. 3 is a gentle breeze, leaves and twigs move, 8 to 12 miles per hour. 4, moderate breeze, branches move, flags flap, 13 to 18 miles per hour. 5, fresh breeze, small trees sway, whitecaps on water, 19 to 24 miles per hour. 6, strong breeze, large branches move, flags beat, 25 to 31 miles per hour. 7, moderate gale, whole trees move, flags extend, 32 to 38 miles per hour. 8, fresh gale, twigs break, walking is difficult, 39 to 46 miles per hour. 9, strong gale, signs, antenna blow down, 47 to 54 miles per hour. 10, whole gale, trees uproot, 55 to 63 miles per hour. 11, storm, much general damage, 64 to 73 miles per hour. Hurricane, widespread destruction, 74 plus miles per hour. Make a Beaufort scale spinner. Here's a picture of what it'll look like. To estimate how hard the wind is blowing, observe its effects and match them up on this spinning Beaufort scale. Here's what you need: a fine-tipped marker, a small plate, 2 sheets of heavyweight paper, ruler, scissors, paper, fastener. Here's what to do. Trace around the paper plate to make a circle on one of the sheets of paper. Divide the circle into 12 segments, using the ruler to draw straight lines. Number the segments from 1 to 12. Note 0 and 1 are on one segment. Referring to the Beaufort scale chart, make a simple drawing on the widest part of each segment to illustrate the wind speed. Under each drawing, write a brief description and the wind speed in miles per hour. Cut out the circle. Cut out a smaller circle from the other sheet of paper. Cut a V shape the same size as one of the segments of the larger circle, taking care to end the cuts before you reach the very center of the circle. Position this circle on top of the larger circle and join with a paper fastener. So it'll look like that. That's what they're talking about. Be a meteorologist. Measure the wind speed. Measure the wind speed at different times of day and in different locations and record it in your log. What kind of relationship do you notice between location and wind speed? Weather lore. Can you use what you know about weather to come up with a meteorological explanation for each verse of this American folk poem? Hint, use your wind chart on page 46 to help. When the wind is from the north, the skillful fisherman goes not forth. When the wind is in the east, that's when the fishing is the least. When the wind is in the south, it blows flies in the fish's mouth. But when the wind is in the west, that's when the fishing is the best. Answer. Because north winds are cold, the fish and the flies are less active, so the fish aren't feeding as much. Winds from the east signal a stormy day. Fewer flies and raw, cool, rainy weather mean the fish will be less active. Warm winds from the south mean the fish will be busier, but there will be more natural food like flies, so catching them may be tricky. West winds are dry and bring sunny weather, and in the warm weather months, the temperatures will keep the fish active, making it great weather for fishing. Ask Mark. I was freezing while I was sledding this afternoon, but when I looked at the thermometer, the temperature wasn't all that cold. Why did I feel so cold? You are probably feeling the wind chill. A nice, cool breeze feels great on a hot day, but wind can be dangerous when it makes the temperature shown on the thermometer feel much colder. This effect is called the wind chill factor. When the wind blows and the temperature is cold, you need to bundle up even more to protect yourself. The U.S. National Weather Service has devised the chart on the next page to help determine wind chill. Find the temperature across the top line and the speed of the wind in the left-hand column. Where the lines meet is the temperature that it will feel like to you because of the wind chill factor. Trying to get the whole picture. Quick take forecast. Your thermometer reads 15 degrees Fahrenheit. Wearing your winter jacket, you start to head for the bus stop, but then you notice the large branches of an oak tree moving in the wind. See the Beaufort scale, page 54. What is the wind chill, and how should you dress? So 15 degrees Fahrenheit. There's your thermometer, 15 degrees Fahrenheit. It's not on the chart, so you'll have to figure it out. Answer. The wind speed is 25 to 35 miles per hour, making the wind chill negative 22 to negative 25 degrees Fahrenheit. Better wear some extra layers under your jacket and, very important, protect any exposed skin with a hat, scarf, and mittens. Weather records. The windiest location on Earth is 6,288 feet up in the air on top of Mount Washington in New Hampshire. The buildings on the top of the mountain are either built into the rocks or are chained down so they don't blow away. On April 12, 1934, the winds roared at 188 miles per hour for 5 minutes and then gusted to 231 miles per hour, still the most powerful wind that scientists have ever measured on the surface of the Earth. The strongest winds of a hurricane, see page 106, have been measured at 200 miles per hour. What are the hardest places to forecast? That would be near the mountains. Weather changes dramatically near the mountains, sometimes in just a few hundred feet, which is a big challenge for forecasters. Mountains get stronger winds and bigger changes in temperature. Air gets cooler as it travels over mountains, making more clouds, rain, and snow there. Sinking air from the mountains warms up, creating heat waves in the summer and bringing sudden thaws in the winter. A tight squeeze. Why is Mount Washington so windy? As wind moves along, it meets obstacles like buildings and geographical features, deserts, mountains, or bodies of water, that can make it change speed or direction. Traveling past a tree, for example, causes the wind to slow down because it uses up some of its energy moving the leaves and branches. When wind is forced over a mountain, the wind from the base of the mountain all the way to the top are squeezed through a much smaller space just above the mountain. Why doesn't the air above the mountain make room? The wind is moving that air along also, and it creates a barrier that only flexes a little, getting all that air through the smaller spot above the mountain, which more air rushing in behind means the wind must go faster to get through. Try it. See how obstacles in your own yard or on the school playground affect wind speed. Use your anemometer to measure the wind at various locations. Take a reading in the middle of a clear open place on the ground. Next, measure the wind next to a garage, tree, or parked car. Take several readings at various heights. Record your observations in your log and compare them. How do the height and size of the obstacles affect the wind speed? And that ends on page 63. Thank you.